All right, so in this video, I want to go over multiple things. So we'll talk about multiplying radicals. I also want to go over how we can rationalize, and I'll kind of do like a little mention on dividing. But before we go into that, there's a couple things that you need to notice when you see this type of problem. So I guess a quick example, a really straightforward, simple one would be if you are given, say, 4 times root 2. And you should understand that this right here, right, is a coefficient, and this is a radical. And so if one's a coefficient and it doesn't have that radical, and this one does, and you're being asked to multiply them, you cannot multiply these into each other. All you really end up doing is just grouping the two together, and that's as much as you can do. But we can also, extend on this and say, oh, what if I'm given 4 times 3 times root 2 times root 3 times 6. And so same idea, right? It's almost like combining like terms in a sense. We have coefficients around here. Those can all get multiplied together. And we have 2 radicals here. Those may multiply into each other. And so just quickly going through this one, we would take 12 times the 3. Oh, what am I saying? 12 times 3. 4 times 3 times 6. And that would give us 72. And then I'd take these 2 radicals and multiply those together, and that's root 6. And then like that's as far as that can go. Asking yourself, can I break this down more and simplify, right, using that from the other video? And if you can't, then you've gotten far enough. And so I want to kind of level up this version of, multiplying again. So maybe you may be given a problem such as, let's go ahead and say 8 root 3 times root 3. So by now we know we can multiply these together. And we completely ignore this 8, it just comes along for the ride. And so our 8 comes down, these 2 make root 9. You might think you're done, you're like, I did it, I'm done. But once again, always ask yourself, if you see a radical, can I simplify this further, or is it a perfect square like it is in this situation? You can actually break that down some more. Remember that what's going on between these two is multiplication, right? They are multiplying, so I'll bring down that 8, I'll bring down that times, and then this is now 3. And from here, it's just your standard multiplication type problem. It would go all the way down to 4, and then you're finished. Okay, so I think that's good off of multiplying. I want to focus on now rationalizing, or like when to rationalize radicals. So if you're given a problem that maybe looks like this, okay, there are times when you have to know when to rationalize. When am I going to rationalize this problem? For sure, this is a radical problem because I see a radical. But you do this when you see a radical in the denominator of a fraction, right? We have our 10 in the numerator, we have root 2 at the bottom. And so just looking at this, you have no context. You should be like, uh-oh, this is a problem. There's a radical in the denominator. I need to rationalize this thing. And so to rationalize, you need to essentially find a way to get rid of this radical in the denominator. And to do that, the easiest way is to multiply your entire fraction, both the numerator and the denominator, so a fraction, by what you're trying to get rid of. Literally like copy and paste. And so I see root 2, I want to get rid of that. So I'll write it here and I'll write it here. And from there, you're just multiplying across, and you'll see what's nice about this, right? So that's 10 root 2, because they can't really, all they do is just group together. Got our fraction bar there, and then now we have root 4. You're like, oh wait, but I didn't get rid of this. That means I didn't finish rationalizing. But because you multiplied that original radical by itself, you've actually now created a perfect square that can be, you could square root this. And so you continue simplifying, right? I'm going to go ahead and keep all the stuff the same in the numerator because I can't do anything there. And now that square root 4 is now 2. Once again, you're like, nice, I'm done. Sorry, not yet, because you have coefficient here and here, you have whole numbers. You essentially, if you ignore this, right, you ignore this info, that's 10 over 2. You could still divide that, can't you? So the final breakdown is now that 10 divided by 2, which gives you 5, and then don't forget to bring this one along, 5 root 2. That problem's finished. We started here, we said, oh no, we rationalize, and it took us through this entire process right here. And so that's normally how that will go. Let's see. I don't think I need to do another example on rationalizing. I think a good thing to quickly go over now for the end of this video would be what dividing rationals may look like. So we've gone over how you multiply them, but it's important to not overcomplicate things for yourself when you're dividing. So for example, if you had something such as, let's call it 12 root 3. Someone gives you this, right? And then you are asked to divide by root 3. So like, okay, if I'm going to divide by root 3, I can just, write a fraction bar and do root 3. And then what I don't want you to do is be like, oh wait, isn't this like, oh wait, why did I write rationalizing? This is meant to be rational. Sorry about that. Dividing radicals. My bad. We'll just leave it like that. Okay. You might be looking back at this and like, okay, they asked me to divide by root 3. Oh wait, there's a problem here. I have a radical of 3. I have a radical in the denominator. Shouldn't I rationalize and start doing all of this work? No. Because what's nice, just like any other dividing, right? Remember, we said these are like terms. You see root 3 on top, you see root 3 on the bottom. You can easily just cancel these out, leaving you just with that 12 by itself, okay? It would be a different scenario, right? Oh my gosh, erasing a lot. It'd be a different scenario if you start with your 12 root 3, and then someone says, oh, why don't you divide that by root 2? Then, okay, you're like, oh, wait, like this, I can't cancel this out. That's not easy, but I still see a radical at the bottom. Okay, let's go ahead and, rationalize and do all that. And so always when dividing, right, try to see if you can cancel something out. It makes your life so much easier. But if not, then okay, follow the steps of rationalizing, go with all of that, and we'll just finish solving this one through. Finish there. All right, I hope that was helpful.